Today we're going to look at how we use indicators. Fortunately, you're coming at this from a perspective you've already used them. We've used phenolphthalein, we've used methyl orange, we've used iodine and starch as indicators of when to stop a reaction, and that's exactly what an indicator is for. It's used to mark the end of the titration, which is the equivalence point, and as I was explaining to you when somebody asked how they change colors, a lot of indicators have these flat planar molecules. These are called the benzene rings. And those benzene rings, if they rotate in a direction due to hydrogen coming off or something like that, or here you see, hydrogen off here, and there's a different structure here. And so this one is no longer a benzene ring. And so what's going to happen is it's going to be oriented in a different direction. Therefore, it's going to reflect light differently, voila, changing colors. And that's why we see that magical color change, okay? So that's what's going on with an indicator. A lot of times we use HIN. A lot of indicators are acidic, and that's exactly how we're going to treat them, as like a weak acid. And so that's why we're symbolizing them as HIN. And so that is just a generic way of showing an indicator. Oops. Calculating the pH at the endpoint, assume the color change is visible to the eye when the ratio of indicator to HIN, or acid indicator, means that 1/10 of the indicator must have actually changed forms. Using the Henderson-Hasselbalch equation and the 1/10 rule, the pH of the endpoint, or the color change, is going to be pKa plus or minus 1. This is a chart in your book. And to answer some of the questions I'm assigning you, you're going to want your book open to this page. Here's one of the indicators we've used, methyl orange. And you see that it's yellow above 4, at 4 it's orange, and below 4 it's more red. And so that's how you start to read these charts. And so another one of our favorites, of course, is phenolphthalein. Let's see if we can find it on here. Here she is. Phenolphthalein's colorless at a pH less than 8, and then hot pink when it gets to a pH of 9. But remember, when our pH curve looks like this, those pHs jump a lot within adding a single drop of base to the reaction. So you might think, gosh, that's a huge pH range, but it's really not, because of these shapes. And so this is where you're wanting to look at where your equivalence point lies. The weaker the acid being titrated, the smaller the vertical area is around the equivalence point, which means less flexibility in choosing an indicator. So what it's saying is this one's a weak acid here. And so notice that the distance from here to here is a lot less than the pH difference from here to here. And so this one has a pH difference of maybe 6. This one has a pH difference of maybe 10. And so you're starting to narrow your field considerably. So your first question, estimate the pH of a solution in which bromocresol green is blue and thymol blue is yellow. So you're going to go look at bromocresol green on here. So here's bromocresol green, and it said it was blue, so that is a pH above 5. And then the other part of the question said that thymol blue is yellow, so you go back to your picture, and thymol blue is where? There you go, toward the top. So thymol blue is here, and it's yellow, and it looks like it's yellow in between the ranges of 3 and 8. So that's where you would choose the answer that the pH must be between 5 and 8 there. And so if you had a 1/10 molar solution made of a strong acid, hydrochloric acid, and you add 2 drops of methyl orange, well, the pH is 1. So if you go to the methyl orange, you can see that it definitely would have a red color red since the pH is less than 3.5. And so you're actually going to be asked to go back and look at some of the titration homework you did earlier and tell me what indicator you would use and whatever. So again, this is one of the most helpful pages in your book that you'll want to be turned to answer all of those. All right, so you got a pretty light homework assignment today. Ought to go pretty fast. Tomorrow we will, or next time we meet, we will be talking about KSP, and it's actually part of chapter 16. And all I do is cover this one section of chapter 16, so I shove it in on the end of chapter 15. And that's our plan. So we got one more, and then we'll be practice testing and testing. So we're wrapping up this unit. In middle of April, it looks like will be our time frame, just so you know.
American doctor has received some level of training in Philadelphia. As I am not one of that six, dear boy, I trust you will not hold it against me.
What do you think, Doc?
It's more what I'm smelling, Jethro. Of the hoppy micro brew variety.